Alright, so today, now that we've fixed my typos, we're going to talk about the probability of A and B occurring and the probability of A or B occurring. And so the word and means they are occurring at the same time, or means one or the other, or possibly both. Okay? Alright. We have a little bit to copy down here, so I'm going to pause this so you can copy and then we'll talk about it. Just to make sure I wrote this right, I'll read it. Dependent events are when the outcome of one event affects the outcome of another event. Independent events are when the outcome of one event does not affect the outcome of another event. Dependent quite often is thought of like if I got a deck of cards here and you draw a card out, what's the probability you'll draw a heart? What is that probability? On a standard deck of cards, what's the probability you'll draw a heart? Out of my deck. 1 out of 4, right? 13 out of 52, which reduces to 1 out of 4. But if you hold on to that heart and I have someone else draw a card out, what's the probability they'll draw a heart? 12 out of, did I say out of 54? Okay, good. Okay, good. 12 out of 51, that's correct. So that first draw has affected, it has affected the outcome of the second one, the second draw. So those events are dependent. Now, if you take that card and put it back in, and I'm back to 52 cards in my deck, then is my second outcome affected at all by the first one? No. Okay, so replacement versus non-replacement means that I might have a dependent event in one situation and an independent in another. Okay? So I'll raise this up. Make sure you copy this down, these two examples. I'll pause while you do that, and then we'll talk about it. The first one here, drawing the ace of spades from a deck of cards, or rolling a 2 on a standard number cube. Dice, games of dice and different things. In math, we refer to them as standard number cubes. Okay? Do they have anything to do with each other? If I draw a deck of cards or I roll a die, does one going to affect the other? So what are they, independent or dependent? Independent. Because it doesn't matter what I draw, right, Garrett? Doesn't matter what I draw out of the deck, it's not going to affect what I roll, right? Okay, looking at the next one then. Drawing a red marble out of the bag. Let's say I have 5 red and 5 green. Okay? In fact, I should probably say 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. Those are all in a bag, those marbles, and we reach in and pull out a red one. What was the probability I pulled out a red one?
1/2.
Yeah, 5 out of 10, which is 1/2. Now I'm holding on to that, and I reach in the bag and I pull out another one. What's the probability I get a green one?
5 times.
5 out of 9. That's different than it would have been had the red marble still been in there, right? Or if I reach in the first time and pull out a green one, and I reach in the second time, what's the probability I'll pull out a green one?
4
4 out of 9, right? So my probability of the second draw is affected by the probability by the first draw. And so that is called what? Dependent. So that's a dependent situation. Okay? All right, we have a property here to copy down. And an example. The probability of A and B. In this situation, we're talking about A and B being independent events. So one has no effect on the other. Okay? And so the probability of A and B occurring is the probability of A times the probability of B. That's the rule. Okay? An example is if we know the probability of A is 1/2, say I flip a coin, probability of getting ahead is 1/2. Okay, and the probability of something else is 1 out of 3, so I've got 9 marbles in the bag. 3 red, 3 blue, and 3 black. And so the probability of drawing a red one would be 1 out of 3. The probability of flipping a head and getting a, what color did I say?
Red.
Red is going to be 1/2 times 1/3, which is 1/6. Okay? Example here. Find the probability of drawing a red card from a standard deck of playing cards and rolling a 3 on a, I probably should have said standard number cube. Okay, well what's the probability of drawing a red card? 1 out of 2, right? A red card is either hearts or diamonds, and the other 2 suits are spades and clubs, right? So there's going to be half red and half black. Or I can look at it as 26 out of 52. Is that what you said?
Yeah.
Okay, good. So it's 1/2 either way. And I times that then by the probability of rolling a 3. What's the probability of rolling a 3?
6.
1 out of 6. And so my probability of getting a red card and a 3?
1/12.
1 out of 12. Probability of red and 3. Okay? Alright, so that's how we do it when they're independent events. We just multiply them together. Okay, I think I have one more page of heavy writing and then a couple examples or one example and then we're done. Mutually exclusive. Go ahead and copy down these examples and we'll talk about them. So mutually exclusive events are 2 events that cannot happen at the same time. So if A and B are mutually exclusive, then the probability of A and B is equal to 0. If they can't happen at the same time, then the probability of both of them happening at once is 0. Okay? So, if we move on to A or B. If A and B are mutually exclusive events, then probability of A or B is equal to probability of A plus the probability of B. Yeah, it's plus. Okay? Now, if they're not mutually exclusive, then the probability of A or B is equal to the probability of A plus probability of B. In addition to that, some of those both happen at the same time, so we have to subtract that group from it. Okay? Because we added them twice. Okay, and so we need to subtract the ones that we added twice, so we only count that once. Okay? So, these are the definitions. Now let's do a couple examples of apply them, and then you can ask some questions if I didn't make it clear enough. Okay, find the probability that if you randomly select a whole number between 1 and 15, you'll get a number that is odd or divisible by 6. Okay, so we want the probability of odd and the probability divisible by 6. Okay, can they happen at the same time? Yes? Okay. What's that?
This isn't the only one that's divisible by 6 and 15 as well. Yeah, which isn't the only
Wouldn't that be mutually exclusive?
Okay.
They can't happen.
Can they, if I expand the numbers, I'm hearing different conversation. If I expand all the whole numbers, can a multiple of 6, a number that's divisible by 6 means it's a multiple of 6, can that be an odd number?
No.
I don't think so, right? What are they? What are the multiples of 6? 6, 12, 18, 24, 30, 36, 42, starting to pause, 48, 54, right?
Yeah, you're always going to get this.
They're all going to be even numbers, aren't they? Okay? The reason they are is because we're talking factors, and it has a 2 in it, and everything that has a factor of 2 is going to be even, right? Okay, so probability of odd is what?
8 out of 15.
8 out of 15, good. What's the probability divisible by 6?
2 out of 15.
2 out of 15, what are they?
6 and 12.
6 and 12. So the probability of odd or divisible by 6 is,
2/5.
it's 8 fifteenths plus 2 fifteenths, which is 10 fifteenths, which is 2/3. Okay? So the probability of an odd or a divisible by 6 selection would be 2/3. Any questions on that? Oh, I'm sorry, go ahead.
Not on that question specifically, but, what if A and B are not mutually exclusive? Do you have an example on that?
Yeah, this one right here. Okay, find the probability that if you randomly select a whole number between 1 and 15, you will get a number that is prime or even.
2 is prime and even.
2 is prime and even, isn't it? Okay? So what's the probability I draw 2? So the probability that I get a prime and even, whoops here. Is 1 out of 15. It's the number 2, right? Okay? What's the probability that I get a prime number? Well, what are the prime numbers between 1 and 15?
2, 3, 5, 7.
2, 3, 5, 7, 11,
13.
13.
Wouldn't it be
That's it.
1 and 2?
No,
Okay.
1's not prime.
Why is 1 not prime? I'm hearing some want prime, some saying no.
Because it's 1 times itself. 1 times 1, it just happens to be.
What's the definition of prime? This is our problem.
The only factors is itself and the number 1.
Okay, it's a little more detailed than that. That's the result usually. But 1 has the only factors of 1 in itself, right?
Yeah.
So the definition of prime means it has to have exactly 2 factors, which are 1 in itself. And with the number 1, 1 in itself is the same number. It doesn't have 2 factors. It only has 1. Okay? So that's why 1 is not prime. So we said 6. Is that correct? Or did I remember wrong? Didn't I go like this?
2,
6.
3, 5, 7. 11, 13. Yeah, 6.
6 out of 15. We're going to leave it that way. Okay? You'll see why in a minute. What's the probability of even? It is.
Yeah.
7 out of 15.
So, never mind,
Wait.
Yeah.
Like, how it says prime or even? That's different than prime and even, correct?
Right.
So like prime or even is all numbers except 1, 9, and 15.
Right.
So, okay. Oh, that's what we eventually.
Yep, that's where we're going to go. The rule said it's the probability of prime plus the probability of even minus the probability of prime and even. Since they're not mutually exclusive, the rule will be the probability of the first event plus the probability of the second event minus the probability of the and, meaning the overlap, where the 2 are together at the same time. And so we said probability of prime was 6 out of 15 plus probability of even is 7 out of 15 minus the probability of both, 1 out of 15. So 6 out of 15, 7 out of 15, 1 out of 15, that's 13 fifteenths minus 1 15th is 12 fifteenths. And that goes along with what Matt just, Max, sorry, I don't know why he called him Matt. That goes along with what Max just said, that the numbers that won't go into there, that are not prime or even, right, are the numbers
1, 9, and 15.
1, 9, and 15. Those are the only ones that weren't prime or even. And so that reduces then to 4/5. So the probability of prime or even is 4/5. Okay? Any questions on that? So you have to know what independent events are. You have to know what dependent events are. You have to know what mutually exclusive events means. And then you either have to get used to writing all the possibilities out to find the probability, or you have to remember these 3 rules. Okay? So it's up to you. All right. Yes?
Is the reason why they're not mutually exclusive is because of the overlap of 2?
Right. Because they have at least one situation where they can both occur at the same time. I can pick a prime number and an even at the same time. It could be the number 2.
That's the only number that's
That's the only one, yeah.
So is it ever affected where there could be multiple at once? Or is that
Yeah, I could have said odd or prime.
Which, like, every number except 2 is odd or prime, is odd and prime. No,
No,
almost all.
it would be just the evens that are left. 4, 6, 8, 10, 12, 14. 4, 6, 8, 10, 12, 14. So it'd be 6 and could. Sorry, I'm speaking softly now. I lost track of what was your question? Could there be more? Yes, it could. I could have said, instead of prime and even, I could have said prime and odd. And then this would have been, how many odd ones were there?
almost all of them except
Well, there's 8 odd. And there were 6 prime. And then the odd ones that were prime was 3, 5, 7, 11, and 13, right? There were 5 of them. So I'd have to subtract those 5 out of 15.
Oh.
Okay? All right, any questions on that? Okay. So remember, we're doing 1 through 39, odd today, 9, 7. Quiz today, quiz tomorrow over 94 through 96.